Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and as an operations researcher. Okay, today we're continuing with our tutorial essentially of Optimal Economist, my latest commercial software package. It's an implementation of Larsonian Econophysics. If you haven't already, I strongly recommend that you read the paper Theory of Microeconomics and Macroeconomics, Larsonian Econophysics. You can find it for free on the web. It's a PDF, version 2. I've done screencasts, going through the whole thing. So you should do that before you go through the screencasts of this. Now, to date, I've done all the microeconomics layouts, so we're going to start with the first of the two macroeconomic layouts today. So we're at the main menu. It's very simple. You just click countries here, and I just have the U.S. in. I know there's a lot of data here, but I have a lot of tooltips. So this is a tab, country info 1, country info 2. We're going to try to cover all the fields for country info 1 today. So the country or region is here. USA, of course, account code USA. The current central bank chair, Mr. Jerome Powell. I don't know, you can leave that off if you want, but I'm sure he's going to be out of there sooner rather than later. And the address, and that's actually the phone number, and there's his email, incidentally. Alright, so here, you put in return to capitals a decimal. I'm using 0.300, 30%. Return to labor, 0.7 or 70%. Those are the standard amounts, okay? I've seen some books which will say maybe 0.33 and 0.67, but the standard is usually 0.30 and 0.7. The depreciation rate, we're assuming, is 6.6%, or in decimal terms, 0.066. Number of points is 11 past points, and then future is 5. And this end pulls here that's for advanced users only. Don't worry about that. Alright, starting in any years of the past data, I'm going from 2005 to 2015. Remember, all currency amounts are expressed in the base year terms. So if you're starting in 2005, everything here must be in 2005 base year terms. And occasionally the Federal Reserve will change the base year, so you have to be cognizant of that. Alright, this looks like a lot of work, and it is, but here we go. The first column here is a capital K. First row is a capital K in, let me see if I can get the tool, in the starting year. The values for the following years are calculated from the observed investment rate, which is here. Okay, so you don't have to worry about that after the first year. So here you enter observed values of private domestic investment for each year. And please use a scientific notation. Okay, you see the scientific notation here? E minus, whatever. Or E plus, I should say. Better be E plus. Or just E in the number. These are very tight because I had to get a lot of data in. So, I mean, this is a simulation, basically, of a whole country or region's economy. So, it's going to be this complicated. So, Y volume is the observed change in capacity utilization. Assumed to be the same for both goods and services. Leave the first row blank. Okay, because you don't know what that's going to be. C-res. These are the calculated changes in the consumer reservoirs based on the change in investment amounts. The first row will be blank. So this column here is calculated. And here are the calculated decimal effective rental prices of capital, which you can see are actually pretty high. The number of employees for each year using scientific notation. Okay, and this includes actually both full and part-time, incidentally. A volume, these are the calculated ratios of the current year number of employees to that of the previous year, so it's a ratio. Very important number there. The wage W, leave the first row blank. These are the calculated mean wages, including fringe benefits. That's important. You have to include fringe benefits here. But these are actually calculated, frankly. Okay, so here's the decimal changes in the nominal, nominal base wage rates. And you leave that blank. In fact, that's how we get the wages for here. A prod, this is the observed decimal change in output per worker. This is the productivity. You leave the first row blank. So as long as you read the tooltip, you'll be okay. Okay, go imports. Enter the observed values for imports for each year, again using scientific notation. Delta is the change. These are the calculated decimal changes in imports divided by the previous year's one. So the first row will be blank. Exports go in this column. These are the observed exports for each year using scientific notation. And then the delta. So obviously the first row is going to be blank, and then this is the change in exports. And this is the calculated values of exports minus imports. So you can see the imports are greater than exports. It's the way it's been in this country for many, many years. And here's the value of the monetary base. This is high-powered money. It's M0. See, M0. M0 is the proper, that's the hard currency. We don't want to use M1 or M2 here. M0 is what we want. And then all these columns here are the projected values, okay? And you have to perform the calculation. If you changed any of these things, if you've added numbers as you would normally, then you have to update the projections, okay? Comprende? Okay, continuing. This is GM0. These are the calculated decimal changes in the monetary base. A negative value, let me just read my own tooltip here if I can. Negative value means an injection into the consumer purchasing power stream, okay? So that's injected into. These are the calculated decimal changes in the monetary base which actually get into the purchasing power stream instead of being held up at the bank, for instance. If the Fed prints a lot of money but it's only stored in the bank and doesn't get into the purchasing power stream of the consumers, then it has no effect. So this is the effective G. Now here's the optimal values. These are all calculated. This is the optimal change in the monetary base, M0, which would give us 0% inflation. Okay? 0%. And here are the observed values of inflation in percent. Leave the first row blank. These are observed. So you need to know what the inflation values are. Take the ones from the government. Use CPI. Of course, you could use other indices if we wanted to. And here we have the GDP observed in scientific notation. And here's the growth rate, which is calculated, so you don't have to worry about that. The growth rate in GDP. G is the expenditure of the federal government for each year using scientific notation. Okay? C is the calculated national consumption. So you don't have to worry about that. The program will calculate that. S is the calculated national savings, both public and private. The tau KW, these are the calculated values of the effective tax rate on capital and labor, assuming to be effectively equal. That's one of the assumptions here. By the way, another assumption is that we accept the twin deficit hypothesis. That is, that the trade deficit is equal to the federal deficit. Okay, that's very important. WB, these are the calculated wages that are due from the investments of the workers, WB. So it's the investment income per worker. And here's the calculated tax per worker. And here's the disposable income. This is all calculated, so you don't have to worry about that. And the small c is consumption amounts per worker. The big C is the consumption for the whole country. This is consumption per worker. By the way, it's per worker. It's not per resident of the country. And this one, S, these are the calculated savings per worker. That's small s, versus big S here. And SR, calculated decimal savings rates per worker, which includes Social Security, incidentally. And then these are the projected values of all those columns. And then I still have some more down here. These are the projections with GDP using individual projected factors rather than past values of GDP. Okay, that's one way to do it, and that's the calculated growth rate. Doing it that way, the mean value of GDP observed and GDP with the factors, and then the growth rate using the mean factors. So this is just an alternative means of calculating, what's in this column here. Well, I know that's a lot to take in, but you can see that the program calculates as much as possible from the data that you input. So you would just come, wherever you see these tabs here, this is where you can add additional information, and then the program will compute all the other columns for you. Okay. So you click here for graphs. We'll cover graphs after we cover the second layout. I know that's a lot to take in. It's involved, but I mean, where else are you going to find country data like this on one of two layouts? It's pretty amazing. I packed everything in, just took two layouts. The program calculates as much as possible, everything that's needed, so as to minimize how much input you have to put in for each country you wish to work with. In terms of cost, we reduced the price of this program from $295 all the way down to $95. And it's real simple. You just use PayPal, send transpower at AOL.com, $95, and we'll send you the Dropbox link, or you could buy it directly from Amazon, either way. We provide free email support for the life of the product, and so we'll take care of you for sure. That wraps up today's screencast. Next week, we're going to go over layout 2, and I'll just give you a quick glimpse of that. If I click here, here's layout 2. It's a little bit less crowded. And then after that, we'll look at the graphs. Alright, so I'm going to close out, and that's it. We're back to the main menu. Again, thank you very, very much for your attention, and please subscribe to my channel, like this video, And leave a comment or ask a question. Be happy to answer any questions. We're friendly here. Alright, until next week, be safe and sound and stay prosperous.